usually when talking about microservices is that you hear a lot about success stories from large industry players, for example, from Netflix, Amazon, and eBay, just to name a few. And when you look at those success stories from a startup perspective with far less resources in this large scaling world, you may up ending saying, well, that's fantastic, let's copy that. But the problem is what works in one organization might not work for you. And the reason for it is that each journey is different for every organization. So one of the reasons why every journey is different is because every organization is facing different circumstances. For example, your team size, your structure, and also your skill set is affecting your journey tremendously. For example, if you are a small team with little DevOps practices in place, it will definitely impact your transformation velocity itself. And if you take into consideration that you still have to take care of your legacy system, which needs to be maintained, it reduces the time that's available for your transformation process. And also your runtime environment is also affecting your journey. To implement new features in a very short period of time, you might struggle with the decision where to implement these new requirements. And so it's really important that you watch out for your affecting circumstances to figure out which circumstances are holding you back and which slowing you down, and have to adjust them accordingly. And to give you a little background, so I am Susanne Kaiser. I used to be the CTO of Just Software. Just Software is a startup in Germany, in Hamburg. And at Just Software, we are developing Just Social. That's a digital workplace providing apps for communicating and collaborating in your teams. Started with a monolith in every aspect. So we had one team working on one collaboration unit and one collaboration product based on one code base, based on one technology stack. Our team was growing, and also we added more and more features. The code base became bigger and bigger, and the number of users increased. So this is supposed to be very fantastic, but instead it felt kind of clunky after time because everything was tied together. From the organization standpoint, the thing is that it took a long time to get things done. For example, discussion, meetings, decision took far longer than before. And with no responsibility clearly assigned, no one felt responsible right away. For example, when a bug arose, it took a while, someone felt responsible to fixing it. So our processes were slowing down, and such, meaning that our productivity suffered. And also from the product perspective itself, the more features we added, the more complex its usability became. And the usability and user experience suffered through continuous feature amendments. And instead of solving our users' problems very well, very easily, we were increasingly confusing them. And also from the software architecture perspective, it's quite difficult to add new features without impacting the entire system. And it's quite complex to release new changes since we have to rebuild and redeploy the entire monolith, which resulted in high-risk deployments, which happened less frequently, so new features got released very slowly. So more than 3 years ago, we changed our product strategy, and we were focusing on usability and user experience improvements. And we were dividing our one app, our one solution, in separate collaboration apps. And each one of them is taking care of a specific use case, having one problem very well. So we introduced the idea of having different collaboration apps for sharing documents, for communicating in real time, for managing your tasks, but also sharing corporate news and also editorial content throughout your entire organization. And in the meantime, we also split our one team into multiple smaller teams and assigned to each of them well-defined responsibilities, to assign to each of them a specific set of collaboration apps to enable them to work at different parts of the software itself independently at their own speed and pace. And as a next logical, reasonable step is to reflect this flexibility and autonomy also in our software architecture by introducing microservices as well. And this this journey to microservices was mostly triggered by organizational and product impact. So our motivation was to enable our autonomous teams, or to enable autonomous teams in general, to work at different parts of the software independently and at their own speed with minimal impact across the teams, and develop and deploy the collaboration apps independently and scale them also more effectively to have, in the long run, to release the changes quickly. So when you start this journey, the first thing that you have to do is to identify good candidates. And to think of good candidates, you have to consider the key concepts of modeling good microservices. And the key concepts follows the principles of high cohesion within the service and loose coupling between those services. For us, in our case, we used our collaboration apps as high-level bounded context to represent coarse-grained service boundaries as a good starting point to divide them in finer-grained services later on. And we started our journey with decomposing the Just Drive collaboration app, which takes care of document management. So the thing is that the new service that we established was not an exact equivalent to the current one. Instead, we modified the user interface, we added also new features as well, and we made significant changes to the data structure itself. And this service itself owns the document exclusively. That means that the only service that can read but also modify the document itself. And now the question is, how can we share this data? How can the services interact with each other? To avoid requesting the author relevant profile data each time when we're displaying the monolith, what we did is we introduced a local copy which resides in the document service itself. So what it does is the monolith itself publishes a profile updated event to the message broker, which our service is subscribing to and consumes this update event and updates its replicated data accordingly. So in general, a coexisting service from scratch is in general a very good decomposition strategy. But in our case, in our specific case, we did too many steps at once. So as I mentioned before, we also introduced a new user interface, but also added new features to it and made significant changes to the data structure itself. So for us, it was not an optimal approach to start with. And the thing is that we get very late results because we put so much load on our shoulders that we got really, really late results. And instead, and especially in the beginning, it's very critical and very crucial that you get early results, that you can gain early experience with microservices and also gain confidence in handling microservices itself. With the next service, we followed a different approach. So we followed the approach of an incremental top-down decomposition. And so we used, as the next candidate, we used our chat app to decompose. And with this one, we extracted the user interface first as a separate web app. And we provided on the monolith side the REST API that the REST client could address. So in the next step, we were going down further and then also extracted the business logic. At this point, we are still sharing the same data storage, but in order to become a standalone decoupled service, you also have to split the data storage so that the new chat service can own the chat state exclusively. So when you have multiple candidates for microservices, there's also kind of challenge which one to take first. And so in contrast to what you have done, I would suggest that you should start with those ones that are easy to extract. That could be small services that have very few dependencies, because when you start with small services that are easy to extract, you are getting very early results and can gain early experience with microservices in particular, but also with the decomposition process in general. So, but with every service that we extracted, we got confronted with security aspects in terms of authorization. Solving authorization caused us a lot of headaches. And as a consequence, we postponed handling distributed authorization. But what happened as a consequence was very counterproductive. Because with every service we wanted to introduce, we end up with the same question, how to handle authorization. And one consequence was, okay, let's put authorization to that place where it's already solved, and that was a monolith. So we were feeding the monoliths again. And another consequence was, okay, let's re-implement the authorization, let's implement it on service level. But what happened is that we re-implemented cross-cutting concerns on every service. The consequence was that the first glimpse was, okay, authorization belongs to the main model, but because it was controlled by its collaboration app, but we missed the inter-service dependencies. So we were copying data back and forth and introduced the risk for collision. So to avoid feeding the monolith or re-implementing a cross-cutting concern on every service is handle cross-cutting concerns from early on, which we didn't. So to make a long story short, so we introduced a centralized service, authorization service. And when introducing a centralized service, there's another challenge that's coming up is that you introduce a distributed monolith. So when you modify one side of your system and you have to adjust the other side of the system simultaneously at the same time, it's a strong indicator that you have introduced a distributed monolith. So, and when you update one service or introduce a new service and you have to adjust your centralized authorization service at the same time, you're combining disadvantages from both worlds. So you still have the tight coupling, but now communicating over a slow and unreliable network. A solution for this is to provide one stable common contract that the centralized authorization service owns and each other downstream service translates to, that conforms to. So each collaboration app has to translate their authorization-related actions into this one stable common contract, and without explicit translation on the centralized authorization service. So whenever you change one service on the one side or introduce a new service on the other side, you don't have to touch the centralized authorization service. But there's another prerequisite that this common contract remains stable. So if this common contract is not stable, then you're flipping the problems to the other side. When you introduce microservices, you have to figure out how your services shall interact with each other. And in the request-driven service interactions, services are calling each other directly over their API. So this gives the service the opportunity to control the request flow when there is synchronous processing. In the event-driven service interaction, the services are not communicating directly with each other. Instead, one service publishes events to a message broker, which other services subscribe to and consume those events independently at their own pace, which increases decoupling and pluggability. So another question that arises when introducing microservices, how these services shall share data. So in a hybrid model, we have a combined pattern where services are communicating via events, but only for notification purposes. In case additional data is required from another context, the service has to do a remote cross-context query directly to its source. To avoid this remote request, you can internalize them based on a local copy. To avoid requesting the author-relevant data from the profile service, each time we are displaying a document, we are keeping a local copy inside our service. And to keep this local copy in sync with the original data, we have to get notified or we have to subscribe to the profile updated event. And in this case, the events are not used only for notification, but also for data duplication and state transfer itself. And another data-related aspect to consider is the source of truth. So in traditional event-driven systems, services are usually listening to events, saving their actions to the database, and emitting new events. So for the service itself, the database is the source of truth. But for all downstream services, the events are the source of truth. So this comes with complex abilities. On the one side, you have dual rights. You have to update the database, but also publish events to the message broker, and you have to figure out a way to keep this consistent. And on the other side, the model of the database, the data model of the database and the events can diverge very easily. So an alternative is to merge these two by retaining the events long term. So in this case, the events are used internally, but also by all downstream services as well. And here comes Kafka into play, which is well suited for keeping events long term to be used as an event store. Kafka is a distributed, fault-tolerant, scalable commit log service, which was originally created by LinkedIn. And it combines the capabilities of a messaging system, a storage system, and also a streaming platform. So to give you a quick overview, a stream itself is an unbounded, ordered sequence of structured data records, which are continuously updated. And a data record itself is defined as a key value pair. When you start your service in a streaming context, what happens is that a Kafka topic is loaded into the stream of your service, which can be processed in the scope of your service itself. A Kafka topic is a logical category where you can publish events to, but also subscribe to from other services and to consume events. And what makes Kafka streams very, very powerful is that it makes data available wherever it's needed. It's running in the same process as your service. You don't have to make a remote call to, for example, to the broker itself. Also, when you implement stream processing, you typically need a stream and also a database for enrichment. And the Kafka Stream APIs provide those functionality by abstracting by providing some abstraction over streams and tables. How can we use this? We can create a stream from the document topic, and to enrich this data with the author-relevant information, we can create a table from the profile topic itself. And after that, we can join the stream and the table together into a new state store, which is accessible from the outside, for example, by a REST API, to be used as an inbuilt materialized view. To compare the event-driven approaches is that Kafka Streams reduces the overhead that goes in with the other event-driven approaches. A local copy is not necessary anymore. So it reduces the overhead to duplicate this copy and also to keep it in sync. So, and Kafka Streams themselves also pushes the data wherever it's needed, pushes into the same service and the same process of your microservice. This increases the pluggability as well, and it reduces overhead, increases performance and autonomy, which then lowers the barrier to entry for new services. So for new services, you can only plug into the Kafka Streams themselves and can run them right away. What we have learned so far is that it's definitely better to start with small services that are easy to extract and take one manageable step at a time. Don't put too much load on your shoulder, especially in the beginning, in order to get very fast results and gain early experience with microservices. And to handle your cross-cutting concerns from very early on, to avoid feeding your monoliths or re-implementing cross-cutting concerns on every service, as we have done before. And designing your system event-driven to be easy to evolve continuously and incrementally by using event-driven service interaction, but also consider event stream as well for achieving high pluggability and high performance to lower the barrier to entry for new services as well. And to come back what I've mentioned before, your transformation process is not running in isolation. It's affected by your circumstances. So watch out for circumstances that holds you down, that pushes you back, and try to adjust them. And to keep in mind, every journey is totally different, and our journey might look totally different than yours. Thanks for listening.